Good morning, everyone. And today, our group will talk about the capacitance and capacitor. In our video, we will first talk about the capacitance, the capacitor in series and parallel, and the energy stored in the electric field.
So what is capacitance? Capacitance is the ability of a system to store electrical charge. It's measured in farads. Capacitor, the components that exhibit capacitance, consist of two conducting plates separated by insulating material called a dielectric. When a voltage is applied across the plates, electrons accumulate on one plate creating a negative charge, while the other plate becomes positively charged. This creates an electric field between the plates, storing energy in the electric field. The amount of charge stored per unit voltage is the capacitance, and it's influenced by the surface area of the plates and the distance between them. So, how capacitance works? It works by storing electrical energy in an electric field between two conducting surfaces, usually separated by an insulating material called a dielectric. When a voltage is applied across the plates, electrons accumulate on one plate, creating a negative charge, while the other plate becomes positively charged. This separation of charge creates an electric field between the plates, storing energy. The capacitance, usually measured in farads, determines how much charge can be stored for a given voltage. Increasing the surface area of the plates or decreasing the distance between them increases capacitance, while inserting a dielectric material further enhances capacitance by reducing the electric field strength and allowing more charge to be stored for the same voltage.
Now, what is a capacitor? A capacitor is a passive electric component that stores energy in the form of an electrostatic field. It stores that electrical energy by accumulating the electric charges on two closely spaced surfaces that are insulated from each other. Now, how does it work? It consists of two conductive plates that are separated by an insulating material called dielectric. Now, when the voltage is applied across the plate, it causes an electric charges to accumulate on them, creating an electric field between the plates. This electric field stores energy in the capacitor.
Now, let's tackle about how does a capacitor and capacitance related to each other. Capacitance is a fundamental property of capacitors, representing their ability to store electrical charge per unit voltage. It depends on factors such as capacitors' geometry, dielectric material, and the number of plates. Let's give it an example. Think of a capacitor like a water tank. The tank has the ability to store water, just like a capacitor can store electric charge. Now, capacitor is like the size of the tank. A bigger tank can hold more water, and likewise, a capacitor higher capacitance can hold more electric charge. So, in simple terms, capacitors and capacitance are related in the way that the size of the tank determines how much water it can hold. A large capacitor means the capacitor can store more charge, while a smaller capacitor means it can store less charge. In electronics, capacitors are often connected in different configurations to achieve desired circuit characteristics. Now, let's explore the capacitors in series. When capacitors are connected in series, their total capacitance decreases. This means that the combined effect of multiple capacitors in series is less than that of any individual capacitor. To calculate the total capacitance in a series connection, we use this formula. Total capacitance is equal to 1 over 1 over C1 plus 1 over C2, and so on and so forth. We take the reciprocals of each capacitor's capacitance, add them together, and take the reciprocal of the sum. In series connection, the voltage across each capacitor is the same. This means that the applied voltage is distributed across all the capacitors equally. It's important to note that the total energy stored in capacitors decreases when they are connected in series. This is due to the decrease in total capacitance. Now let's move on to the capacitor in a parallel. When capacitors are connected in parallel, their total capacitor increases. This means that the combined effect of multiple capacitors in parallel is greater than of any individual capacitor. To calculate the total capacitance in a parallel connection, we simply add up the capacitance values of all the capacitors involved. In a parallel connection, the voltage across each capacitor remains the same. This uniform voltage distribution ensures consistent performance across all the capacitors. In summary, connecting capacitors in parallel results in an increase in total capacitance, consistent voltage distribution, equal charge distribution, and enhanced energy storage capacity.
Energy stored in a capacitor is electrical potential energy, and it is thus related to the charge Q and voltage V on the capacitor. A capacitor stores energy in the form of an electric field between its plates. The energy stored in a capacitor is electrostatic potential energy, which is related to the charge and voltage between the plates. Electric field energy in capacitors. The ability of a capacitor to store energy in the form of an electric field and consequently to oppose changes in voltage is called capacitance. It is measured in the unit of the farad. Capacitors are used to be commonly known by another term, condenser, alternatively spelled condensor.
That is all, and thank you for listening.